This conference will now be recorded.
In our today's video, I'm going to explain you corrosion and rusting. If you guys remember, we have been doing about properties of metals and non-metals, and we described chemical and physical properties of them, also listing down some uses of metals and non-metals based on their particular properties. So please grab your chemistry copy books and write down the topic and the lesson objective. We're going to look at two things today. We'll describe what happens during corrosion and rusting and some methods of preventing metals from rusting. So let's get started. When metals, any metal, is left in the contact with air and or water, they corrode. So basically, you probably have observed it in your life. Metal objects, when they are left in the air and water, they change the color and they don't look shiny as they did before. So they lose one of their properties. And so that process is actually a chemical reaction, and we call this corrosion. Corrosion is a chemical reaction when metal reacts with oxygen and forms oxide layer. You can see lots of examples of it. It can be copper reacting with oxygen forms copper oxide, tin reacting with oxygen forming tin oxide, and etc. I wrote down here an example of titanium reacting with oxygen and forming titanium oxide. You can see the same example in your Exploring Science book, and I hope if you read book and you listen this video, you're going to remember it better. Titanium has a use in making roof panels, and titanium naturally corrodes when it's left in air, and it forms the oxide layer. But later on, that oxide layer on the surface acts like a barrier and doesn't allow the metal to corrode further and make this metal corrosion resistant. So corrosion, once again, let's say what's corrosion? It's when a metal is in the contact with water and oxygen. But when it comes to rusting, it's the same process, the same chemical reaction, but when we say rusting, we specifically mean corrosion of iron. When iron is in the contact with oxygen and water, it rusts and forms hydrated iron oxide. If you are asked to write a word equation for that reaction, it's going to be the following. Iron plus oxygen plus water forms hydrated iron oxide. You can, if you don't remember that word, hydrated iron oxide, you can say iron hydroxide. There are some factors that affect the rate of rusting, that increases the rusting process. We're not going to look at them all, but I will mention only one, which is salt or salty water. People who live by the seaside often claim that their objects, metal objects, their cars, their bicycles, go rusty faster. Why does it happen? It happens because of the salty water. So salty water increases rusting process. We're almost done with our first objective. We described what's corrosion, we described what's rusting, and as the second objective suggests, we need to talk about preventing rust. Rusting is a very costly chemical reaction and it's not useful. Lots of things around us are made up of metals based on their different properties. like being hard, being shiny, being good conductors. But if we use metals to make some substances, some objects around us, after some time, metal rusts and they lose some of their property, like being shiny, being hard, because rust weakens the metal. It spoils the appearance of metal. So rusting is not a useful chemical reaction. We need to stop it somehow or prevent it from happening. I list down here some of the methods, and you can remember it easily by thinking of your own experience with your bicycle. For example, one of them is painting. So what is the point of all these three listed down here? We want to block somehow the contact of metal with oxygen and air. We need to put a barrier between them. It can be done by painting, by plastic coating, oiling, or greasing. All of them work in the same way. They act like a physical barrier and they don't allow oxygen and water to contact with the metal. There is another method called galvanizing, which is used to prevent iron and steel from rusting by coating these metals with the zinc, specifically with the zinc. And how does it work? Zinc stops oxygen and water from reaching the metal underneath, which is iron or steel alloy. It forms like a physical barrier, but at the same time, zinc acts like a sacrificial metal. What does it mean? I will try to explain it in more detail. So if you look at here in the reactivity series of metal, which shows us which metal is more reactive, meaning that how fast they react with other substances, and which ones are less reactive. You don't need to remember all of them by heart for now, but I would like you to focus on two metals over here, zinc and iron. So as the reactivity series tells us, zinc is more reactive than iron. When zinc covers the surface of iron in a process called sacrificial protection.
This conference will now be recorded.
So in sacrificial protection, we are going to use magnesium or zinc, which are both, let me show you, magnesium over here and zinc. Both of them are more reactive than iron. So when iron is coated with magnesium and zinc, iron is protected from rusting because the more reactive ones, zinc and magnesium, they are going to corrode first, and iron will not. After some time, anyway, this corroded zinc and magnesium need to be changed. But our main metal, iron, is left without rusting. In the next two slides, I'm going to explain and try to explain what is needed for iron to rust, as I said before, but there is an experiment which shows what conditions are needed for iron to rust. We have four test tubes. I'm going to do this experiment as soon as school starts, so you will do it yourself, you will remember it better. We have four conditions. We have four test tubes.
This conference will now be recorded.
I'm going to read what's written here. So we have 4 test tubes, and in each of them we have iron nail. What we are trying to investigate, we're going to investigate what conditions will allow this iron nail to rust. In our first tube we have dried air and calcium chloride. Calcium chloride is acting like drying agent. In the second one we have distilled water and air. In the third one we have boiled water and layer of oil. And in the last one we have salty water and air. If you wish, you can stop the video now and try to predict in which test tube will rusting happen, in which test tube it will not happen, or if you even go beyond that, you can tell me which one will rust quickly. In this table, I tried to list down the conditions and the results. It would be better if you yourself come up with the reason why they will be rusting or why there will be no rusting. So in the first one, we had air and calcium chloride, and as I said, it's like calcium chloride acts like drying agent and dries out the air. So there will be no rust because there is no air. Both air and oxygen should be present for rusting to happen. In B, we had air and distilled water. Everything seems fine. There will be rust because both air and moisture are present. In C, we had boiled water and oil layer. There will be no rust because there is no oxygen. There is no oxygen because by boiling the water, we get rid of oxygen dissolved in water. And by putting oil layer on top of the water, we also prevent any oxygen molecule entering the water. So there will be no rust because there's no oxygen. And in the last one, we have salty water and air. Again, everything seems fine, and even rusting will happen faster because if you remember, we said that salt increases the rate of rusting, so it will speed up the process of rusting. For now, that's all about corrosion and rusting. I hope you found this video useful and helpful. So we have been talking about the process of corrosion and rusting and ways of preventing corrosion and rusting.